In this Gen Chem 1 video, we're going to work some problems on average atomic mass. Our first problem states, on the fictional planet Mang, the isotopes of the element chromium have the following natural abundances. So we're given 3 isotopes of chromium, we're given their percent abundances, and we're also given their atomic masses. What is the average atomic mass of chromium on the planet Mang? So the average atomic mass is the value that you see on the periodic table under each element symbol. And that's what we're solving for. So we need to use the appropriate formula, and that would be that the average atomic mass is equal to the sum of the isotope masses multiplied by the decimal of their percent abundances. So we know the formula. All we have to do now is just plug our values into the formula. We have our isotope masses, that's been given, and we have our percent abundances, that's also been given. Once we solve, we should get a final answer of 52.19 AMU. Remember that AMU stands for atomic mass units. Lastly, do not forget to use the proper significant figures. In this problem, we should have 4 significant figures because that's the smallest amount of sig figs that we have in our formula. Okay, let's do another problem. The element nitrogen has 2 naturally occurring isotopes. N14 has a mass of 14.003 AMU, and 15 has a mass of 15 AMU. Determine the abundance of each isotope. So we're given their atomic masses, but we're not given their abundances, right? And so that's what we're solving for. We need to look at the periodic table and find the average atomic mass of nitrogen. Once we do that, we see that it's 14.007 AMU. Now we can use the same formula that we used in the previous problem to solve for their percent abundances. So we know the average atomic mass. We obtained that from the periodic table. And we know the isotope masses. That's been given to us in the problem. But we don't know the percent abundance. So that's what we're going to solve for. Let's plug the values into the formula. And once we do that, we have to set the percent abundances as variables. So we're going to set the percent abundance for N14, which is the lighter isotope, as X. And we'll set the percent abundance for the heavier isotope, N15, as Y. So we know that the percent abundances have to be equal to 100%. So if that's the case, we can actually rearrange this equation down here on the bottom and set Y equal to 100 minus X. So once we do that, we now have to set up the equation with that newly defined variable included. So let's go ahead and do that. You can do this on your own sheet of paper. Okay, so now we've rewritten our equation to include the newly defined variable y. As the equation is, we can't really solve for the variables because we need to simplify the equation. So the first thing that we need to do to simplify the equation is to multiply both sides by 100. Okay, so we multiply both of these sides by 100. And once we do that, we also see that we can simplify it even further. If we're multiplying both sides by 100, then that means that the 100s on the bottoms are going to essentially disappear. They're going to cancel out. And so we'll be left with 14.003x plus 1500, because we're distributing everything, minus 15x, and this would be set equal to 1400.7. Okay, so that's what we get on the left. Now that we have distributed everything, we have simplified it, but we could still simplify it even more. And that's because we have x variables and integers. So we need to combine these like terms. Once we do that, we see that we can also simplify it even further by factoring this x out. So once we factored out the variable x, we can simplify it still even further by isolating x and having the x to be on the left side of the arrow by itself, the left side of the equal sign by itself. The way that we do that is we just divide by 14.003 minus 15, and we have to divide both sides by this value. Once we do that, we should get that x is equal to 99.60%. So if x is equal to 99.60%, we can now solve for y. Remember that y is equal to 100 minus x. So that means that y is equal to 100 minus 99.60. You should get a final answer for y of 0.4%. And so our final answer is N14 has an abundance of 99.60%, and N15 has an abundance of 0.4%. If you wanted to double check to make sure that you actually did this correctly, you would add 99.60 to 0.4%, and you should get a value of 100%. So I hope that you found this video helpful. Thank you guys for watching it. And remember to share, like, and subscribe. Leave your questions and your comments below, and follow Amakemist on social media. See you next time.